So, today I'm about to avoid the general presentation about the Webb and go straight into the present subject. Yet, we also need to grasp that the Webb telescope's discoveries are pushing the limits of our current cosmic hypotheses, and at this very moment, it's on the edge of changing our comprehension of nature and its operations. Researchers want us to understand that ongoing perceptions from Webb have revealed something unforeseen in the early universe, testing researchers all around the world and suggesting that what the Webb telescope found might be a significant issue for our standard model in an exceptional revelation. Space experts have detected a secret of design found somewhere down in the early universe. If you're in any doubt about how important these new pictures are, I want to be in this room, because around me are the researchers, the astrophysicists, the cosmologists, who truly understand how they've changed our perspective on the universe. As indicated by the standard model of cosmology, around 13.8 billion years ago, the Big Bang occurred, and the universe has gone through relentless development since then. However, we all know that the 13.8 billion years period of the universe is incorrect, so hold on for me for this video. When discussing expansion toward the beginning of the universe, it would actually mean that huge objects are getting away from each other. This implies that the galaxies we see outside our Milky Way are drifting away from us. To gauge how far a galaxy is from us, we use something called the cosmological redshift. In a nutshell, the higher the redshift, the farther away a galaxy is from us. Now, light from far-off galaxies takes a lot of time to reach us. It would suggest that the more distant a galaxy is, the earlier in time we see it. But there is an issue. Light from galaxies far away stretches into infrared frequencies, which the human eye can't distinguish. The Hubble Space Telescope can see only from ultraviolet to near-infrared light, which is why it seldom saw very far-off galaxies, with GNZ 11 being one of them, as shown. It existed 13.4 billion years ago, only 400 million years after the Big Bang. This galaxy has a Z or redshift value of 10.95. This made space experts believe that there were very few galaxies beyond redshift 11. Here comes the James Webb Space Telescope, which can detect infrared light, and objects at redshifts of 11 or more can be identified simply by infrared light. So, what's next? Well, we launched the telescope and pointed it towards the sky, and a very different image of the universe began to rise out of the depths of time. The telescope uncovered many galaxies that could be among the earliest known galaxies in the universe. Using early perceptions from the telescope, cosmologists searched for worlds at exceptionally high redshifts, which would show that these galaxies formed earlier in the universe than expected. As the telescope examined the universe, NASA identified a few galaxies that might have been the first to appear in the universe, around 200 to 300 million years after the Big Bang. Very soon, it found the most ancient galaxy in the universe, at a redshift of 13.2, the Glass Z13 galaxy, which formed only 300 million years after the Big Bang. Finding such a number of galaxies in the early parts of the universe suggests that we might have to amend our previous understanding of galaxy formation, said the lead space expert of the finding at the University of Missouri. He also added that our finding gives us the first sign that a lot of galaxies may have formed in the universe much sooner than previously thought. While the new revelation took the entire scientific community by storm, another early-stage universe appeared, this time existing as it were 390 million years after the Big Bang. So, what did space experts find in the latest Webb telescope picture? Well, lately, we've learned about several historic discoveries by the Webb telescope that challenge our normal understanding of how far-off galaxies formed not long after the Big Bang. People are really intrigued by what the shocks are that we're finding. They want to see the beautiful pictures and be told what those photos are about. And they say, well, what's happening? Did you find out something we didn't know before? And, of course, the big answers are, the first galaxies formed differently than we expected, and we don't know why their old forecasts were wrong. Adding to these discussions, the James Webb Telescope has made another critical discovery in the early universe. The Mir European Consortium GTO group recently announced the detection of an incredibly red object that was missed by most deep NIRCam surveys. They tracked down this object while looking for faint sources in the new pictures obtained from the Webb telescope. Faint sources are significant because the Webb telescope captures less light from distant objects, making them appear weak and red in its pictures. While searching for faint sources, the team accidentally found an incredibly red object that past studies couldn't identify. Researchers believe this object could be one of the most distant ever found. However, sometimes adjacent objects appear faint due to dust clouds, but the team has ruled out that possibility. The object seems expanded and has remained similarly positioned for a year, leading researchers to dismiss the chance that it's an Earth-like object in our galaxy. Right now, researchers don't know what the object is. However, in another research paper, they proposed 3 potential explanations. At this stage, analysts initially proposed that the faint object could be a dwarf galaxy with plentiful dust located around 4 to 5 billion light-years away. However, further investigations have made this explanation seem less likely. Another proposed explanation suggests that it could be a distant dusty world that existed 1 to 2 billion years after the Big Bang. But researchers find this explanation unlikely as well. However, the third explanation has gained significant attention, with researchers expressing more confidence in its validity. In their paper, researchers revealed that the object could be a galaxy sharing observational qualities with the recently discovered little red dot galaxies by the James Webb Telescope. Astonishingly, this red galaxy is situated at a redshift of Z, equivalent to 15, indicating its presence only 100 million years after the Big Bang. If this third explanation holds true, it would mark the oldest and most distant galaxy ever observed, testing our understanding of the universe. The discovery of these little red spot galaxies has already perplexed researchers, since they are much more massive and luminous than expected by current models. Now, the discovery of another object significantly further away threatens to disrupt the standard cosmological model, representing a critical challenge to our understanding of the universe. Furthermore, recent discoveries have presented additional evidence against the standard cosmological model. According to conventional standards, galaxies were not supposed to form so early. However, a newfound galaxy dating back around 13 billion years appeared well before the normal development process, including large amounts of dark matter. This early, distant galaxy contains more stars than the Milky Way, despite forming only 800 million years into the universe's 13.8 billion year lifespan. This suggests that these galaxies somehow formed without dark matter aiding their formation, going against the standard model of galaxy development. Well, researchers are now questioning how this is possible. How a galaxy could form without sufficient dark matter to set off the galaxy formation process in the early universe. Claudia Lagos, a professor of space science at the International Center for Radio Astronomy Research, says having these very large galaxies so early in the universe is presenting significant challenges to our standard model of cosmology. This is because massive dark matter structures, which are believed to be crucial in keeping early galaxies intact, didn't have enough time to form this early in the universe. To understand how these galaxies appeared so early in the universe, we need to dive into what happened before the Big Bang. In conclusion, current efforts in this direction are just hypotheses. Some theories propose spiritual elements, such as a designer, while others remain within the realm of physics, like the idea of a multiverse, which involves an infinite number of parallel universes or repetitive models of the universe, where it goes through repeated cycles of birth and rebirth. Nobel Prize-winning physicist Roger Penrose, in contrast, presents an interesting explanation for these large early galaxies in his theory. He discusses the existence of another universe before the Big Bang, although this idea is currently disputed among cosmologists. Penrose's viewpoint is captivating for philosophers of science. It presents new roads for understanding the Big Bang, rising above standard reason and impact explanations. Thus, it serves as a critical experiment for exploring the different ways physics can explain our reality, justifying further consideration from philosophers. With the Webb telescope approaching the last year of its science activities, researchers expect more phenomenal revelations that can shed light on why, how, and when our universe appeared. That's all we have for you today. Hope you all enjoyed today's episode. Thanks for watching.